Alright, we're going to take a minute to think about sidereal and synodic period using this simulation. You're going to revisit this simulation a little later to sort of review some terminology, but right now I just want to focus on a piece of this simulation which will allow us to illustrate synodic and sidereal period. We're going to do that, so let's just take a look here. So this is like a heliocentric model, kind of like a Copernican model going on, and we have the sun here, our observer's planet, so we'll just say that's the Earth, and a target planet, we'll just say that's Mars. Now let's just consider a second the way these things are lined up here, right? We can think about this from sort of this top-down view, like looking down on the whole solar system, and here we see what we're calling opposition, right? So that doesn't really make sense unless we think about it from our view of the sky, right? So that's what the zodiac strip is doing for us down here. You can see that the sun is located here roughly in Virgo. But from our point of view, this planet is on the complete opposite side of the sky. It's 180 degrees away. It's on the opposite side, opposition, right? It's in Pisces here. Right, so this is a significant, we're understanding this from two perspectives. One is our perspective on the planet, and the other is sort of from this top-down view. So let's look again from this top-down view and think about what sidereal period means. What does sidereal period mean? And we're going to focus just on the orbit of the Earth first here. So we're going to set this going. And we'll see that the sidereal period, what that's referring to, is the actual time it takes the planet to orbit all the way around the sun once. So it's physical motion around the sun. That's sidereal period. Now if we look down at the zodiac strip, we'll see that that sidereal period is represented here by the sun passing through the entire sky. It goes all the way through over the course of a year. Right? So that's the sidereal period. If we look back up at the diagram, we can again see that the target planet, also Mars in this case, has its own sidereal period, right? It's longer, it takes longer to go all the way around, but it's the actual time it takes to go from, say, the bottom of its orbit all the way around once. Okay, so that's sidereal period. Now, what is this synodic period really referring to? Well, from this top-down perspective, what the synodic period is referring to is, let's just pause it right there, it's when these two planets line up with each other and the sun. So you see they're kind of lined up with one another right now. You can almost think it like two hands on a clock. When those clock hands line up with each other, that's when we'd start the clock. In fact, there's actually a clock on here, so I'll zero the counter. Okay, and that's when the period starts, and let me play it. And a synodic period is then when those two planets line up with each other again. So right here, right about there. Now what's interesting about this is that that synodic period is not the same as either planet's sidereal period. Right? You'll see that the Earth had to go around more than once, around like 1.5 times to get back to this same synodic spot, whereas this Mars planet only went around a fraction of its orbit. But that's what that synodic period means, like when the hands of the clock will match up. Right? Now we can understand that as well looking at this zodiac strip, what we actually see in the sky and where this idea came from. This kind of connects, I guess, Copernicus's observations, right? The observations that have been made in the sky to Copernicus's model. This happens to be opposition, right? When these two planets are aligned the way they are, right? Because the planet's on the other side of the sun, other side of the sky as the sun. And so the synodic period, if we were looking at the zodiac strip, the sidereal period was just the sun moving. Well, the synodic period is the time it takes for this planet to be 180 degrees from the sun and then come back to 180 degrees away. So let's start the animation and watch down below. So you see they're getting closer. This is so crazy to keep track of all this, right? But from our perspective on the sky, the planet and sun are getting really close together. Right? And of course we can see that from the top-down view. From the perspective of the Earth, the sun and the distant planet are close together. So they appear to line up with each other. Okay, now the planet's getting further away. And again, right about here, oh, I passed it. Let me move the planet. Where were we? Right about here, again, we had 180 degrees apart. So it's another opposition. And again, we see that lines up with this view of the planets, right? That they line up with each other. So we're seeing this idea of the synodic period played out in the sky. The way you could tell a synodic period would be the time it takes for a planet to go from opposition all the way through to another opposition. I hope that makes a little sense. These are kind of confusing concepts to kind of keep straight, but my hope is that looking at the simulation could provide a little bit more clarity.